I wanted to have a few quiet things to do rather than bashing metal all day, just because I have to go back to work next week and I didn't want to be all knackered before I do that. So I started cleaning up and putting together some of the brake components from the parts that arrived last week. So I've assembled the brake return springs. That's these things with the little D-rings. One thing I decided to do was, I'd previously nickel plated some of these parts, but reading up on it, I think nickel's best suited for decorative type things rather than actual corrosion proofing of things. Apparently, unless you've got a full coating of nickel, it'll work almost like a sacrificial type thing, where if there's any holes in the nickel and there's bare steel underneath, it'll sacrifice the steel to maintain the nickel. So the steel parts will rust underneath. So I decided to redo these in zinc. So I cleaned off the old plating with some hydrochloric acid, which took a surprisingly long time. And I set up another little zinc plating bath. So there are recipes for this online. This is really simple. It's basically white vinegar, Epsom salts, and sugar, and then some anodes, which I've just noticed have fallen off in there. I need to get some proper zinc anodes, which you can get from a marine type place because they use them on boats as sacrificial anodes. In this one, I actually used old D-cell battery casings and unwrapped those and made some plates out of those. And of course they get smaller and smaller as they get used up, and one of them's obviously fallen off now. So I'll turn this off. These parts in here are the brake shoe pivots. So oops, it's stuck on there. You can sort of see the bluish grey zinc coating on them. So that'll give them some corrosion proof abilities, and everything will end up painted anyway, I'm imagining, but until then, anything that's plain steel just rusts. So you can see even just these nuts, these pins, all of those, they've just been sitting here. They haven't been wet, obviously. They haven't been outside, but things like that will just flash rust. So hopefully that gives a little bit of protection. Everything will be oiled as well, of course. I'm always very careful with the little split pins to try and not leave jagged pointy bits sticking up, because later on when you go to clean the car or wipe it down or something, you don't want those sort of things jabbing you in the fingers, which of course will happen. And this is my container full of zinc plated parts. I did figure out what was in the little wrapped up package. I got new screws for the end of the dynamo, so I've put those in and just given them a coat of paint. And the other thing was this, which is a terminal block. And this is what goes on there. I'm not sure which way around, it can go either way. But these are, there was a little note with it. So apparently the lids are original, new old stock, and the bases are obviously a replica, but I mean, it's not bad, but it's a little bit rough. You can sort of see where it's all been ground away to make everything fit. I think these are just held in with either silicone or hot glue. They're not straight, and the cover doesn't fit. So there was a note in there that says you may have to drill the hole for this a bit deeper so the screw goes further in. But even if you do that, even if you drill that down quite a way, that screw is not going to be long enough to go through the body and then screw into here. So I'm not quite sure how that's meant to work. But I decided I could probably make a better version of that myself. So I've CAD modeled it up, and I'm 3D printing my own version from ABS plastic, which I know I can sand and make look pretty much like this old resin stuff. Not sure if it would be Bakelite. I think this is some sort of resin, because you can see it's been cast and there's bubbles in it. So For the terminals, I'm just going to use the brass terminals from chocolate block connectors, because you can just screw the wires into those. Printed this in 2 halves. The second half is printing at the moment. I haven't actually checked if the radius is correct, but yeah, it looks like it'll work. So I'll see how that goes. Pretty much figured out how the other parts go. These are the levers that go on the rear brakes, so this is just a temporary shaft. If you look on the car, you can see these are the 2 brake shafts that go out to the cams. There's cams on the end of them, and that's what's operating the brake shoes. So the way this works is this is the front of the car. One of these levers goes to this, and there's a pulley on there. I don't actually have that pulley. I've got an old one somewhere. I may need to make up a new one. They're normally brass, but I'm wondering if I can make one out of some steel, or if that causes problems. Otherwise, I have to try and get a large chunk of brass, which isn't so easy. But you have to imagine the shaft is split in the middle, like the ones on the car, and this bar is keyed with a cotter pin like this to the shaft. I forgot I need to order a couple more of those. And this one is keyed to this shaft. And the way this works is this rod goes to the handbrake. And if you imagine the handbrake being pulled, this pushes on here, which transfers across to this side, and it also pushes on this, which transfers down to that side. So that only puts on the rear brakes. If you use the foot brake, that attaches to here, and that's what goes to that cable. So that goes off to the front brakes too. When you pull on that, you can see it moves it this way, which transfers it through to this lever to this side. So that actuates both the front and the back. This, I believe, is to give you some adjustment as to when the... no, this is to adjust it side to side, I believe, so you get even braking side to side. I'm sure all of that will become obvious when I get it on the car. So that was all nice and simple and relaxing to do. And then I started looking at my fake radiator shell again and thought, I'll just start trying to turn up that flange and see how it goes. That was quite difficult. So normally to do things like that, I use a sort of steel bar with a slot cut in the end, which, let's see, somewhere over here. I was cleaning up before and I put all my tools away, but no. Oh well. If you imagine a piece of steel bar like this with a slot in the end, normally you can use that to slide over the steel and bend it. The problem I ended up having with this is it gets in its own way. So obviously you can sort of do it here, but once you get into places like this, you can't get the bar on there and then bend it. So I came up with a new little tool, which is just a piece of square. Solid square would have been better, but I didn't have any. And I was able to hook that over the edge and then bend it more like that. The other thing I found really useful were these Knipex things, because I was able to use these to start bending the flange down and then get it far enough that I was able to hammer and dolly it. And I ended up modifying dollies to be able to get in there. These tight corners were a little bit tricky, but I found a decent chunk of steel bar. You can use that as a hammer and you just sort of whack it in there. And it worked reasonably well. It's not perfect. And I did find my welds broke. I was expecting that on this side when my fold ended up right along where I'd had to weld on an extra strip because I got this wrong. I was kind of expecting that to happen, so that's why this side is a little bit messy compared to the other side, and it also split in one of these corners, only on one side. So being an amateur with a MIG welder, I just built it all up with MIG and ground it back. But that's not terrible. I mean, it's not great, but it's doable. And I haven't trimmed this flange yet. Really, this needs to be trimmed so it's actually square all the way around. But you can see if you had a fake honeycomb in there, that fits reasonably well, just with a simple curve in it, which is kind of what you would want. I did have a lot of trouble with this piece, and it's still not actually very good. The problem I had, and I've had this problem before, so I should have known about it, is when you bend up the flange like this, you have to make sure it's even. And you're bending over the same distance all the way along so that this fold or this flat piece is affected the same all the way along. And what ended up happening was I ended up bending it a little bit short, just in the middle here. And that made this go completely wonky. I spent ages trying to fix it, stretching it out, hammering it, that sort of thing. And in the end, I gave up. Basically hammered this flange flat again, sort of from here to here, and rebent it. And that fixed it. It suddenly came right. So this is really very rough, but it will serve my purpose perfectly, which I don't know that I actually explained it that well last time I was talking about this. So the idea of this wasn't to build a shell I was going to use on the car. I didn't expect that to happen. This is my first go. I was trying to figure out how to do it. I've kind of learnt a lot from it, and I would do it in a similar way. I might make the joins in different places though. But the idea behind this, also it's still not completely finished. I need to, it's too thick at the moment because this whole bottom edge needs to be bent round 90 degrees as well. But the main reason I need this, if we put it on the car, it kind of sits in there something like that. But the reason I need it is I need something there so I can start building the rest of the body. And that's why I was trying to get the back of it very accurate, because it doesn't matter if the front is wrong necessarily, but the back has to be right because that's where the bonnet has to come to. So I need something to stand in for a decent radiator so I can actually start figuring out the rest of the body. And this one will work fine for that. It's been good fun building it, actually. It's quite interesting, the learning the skills you need to do it. But yeah, obviously I would need a lot more practice. And that's the problem with this kind of stuff, is probably after you've made 5 or 10 of these things, you'd be really good at it. But I only need one, and I don't want to have to make 9 just to get one decent one that I can actually use. So I'll have to see what I do on the actual car when I get that far. So a few people have said, oh, just get one made, but that's, even in the UK, that's not cheap, and you've got people there who can do it. There aren't so many people here in New Zealand who can do it. There are places around, but I'm pretty sure you would be talking to get a full replica radiator made in the right German silver steel is going to be over 10,000 New Zealand dollars. And, you know, that's a lot, basically. So, you know, I want to be absolutely certain that the car's finished and going to be road legal and all that kind of stuff before I invested that sort of money on one piece. So this will do for now. The other thing I did recently is when I moved in here, I bought a new air compressor, the biggest one I could get that would run single phase, and mainly for my sandblasting cabinet. It's been really good for that. But I also wanted to be able to run air tools, and I finally got a little right angle die grinder and some of these Rolock type sanding discs. They arrived yesterday. And it's one of those things where as soon as I started using it, it's like, oh God, I wish I'd known about this years ago. I found with this, it was much easier to grind down the tops of the MIG welds. Got far more control than trying to use a angle grinder. And because it's such a small disc and it's pretty flat, as long as you hold it pretty flat, I was less likely to gouge into the surrounding metal. So this will be something I'll probably be using a bit more now that I know about them. And I think that's kind of it. I'm still waiting on my friend who's going to give me the measurements of exactly where the radiator's positioned on the car, sort of how far back. Again, it's one of those details that it's hard to see. I think somebody did suggest using the length of the hoses, which is a good idea, but I don't have the water outlets, and I think it's different on a Brooklands anyway. And the other thing I've started looking at, or I've asked about, is the Brooklands water pump. So obviously a Brooklands radiator is quite a bit shorter than a saloon car one, and these engines typically work off thermosiphon principle, so there's no water pump normally. The Brooklands did come with a water pump, and I've made inquiries about getting one of the replica ones of those, but that could take a while. Obviously they're not an off-the-shelf item, they have to be made, I guess. So hopefully I've now got my name down to get one of those eventually. But that goes off the bottom of the dynamo housing, the magneto housing, sorry. So the front coverall fits on here, the magneto sits vertically here, and I believe the water pump sits underneath it down here somewhere. So that'll be interesting to see how that's all supposed to fit together and where the hoses and things run. But yeah, it looks far better on film than it does in person. If you get up really close to it, you can see exactly how rough this thing is, and it still needs some tweaking. Trimming this off, which isn't going to be easy now that it's all assembled. Actually, I'll probably have to mark it and grind it down to the right level, and I still need to fold the flange all the way around and put little bottom plates on it. So it's interesting, but this, from the photographs looking at it, if you had a flat line from the top of this chassis rail to the top of this chassis rail, this here, the line would be about here, so that's kind of where it sits, and that's about right for the bonnet height. I haven't actually measured this to see, but yeah, there's very little clearance between the bonnet and the top of the engine, and that seems to be accurate based on pictures of other ones. Another small job I've done in the last couple of days was just some cleanup and modifications to some of my tools. This is my little bead roller. It's just one of those cheap Eastwood style rollers. They're not very expensive, but they're very handy. And quite some time ago I modified it by adding a motor. This is a windscreen wiper motor. You don't need a lot of speed, but you do need a lot of torque. And these little motors are surprisingly torquey because there's a worm gear inside the gearbox here, and quite a bit of reduction. So these move nice and slowly. They're often 2-speed as well, so you can pick which windings you want to use and choose the speed. But this has always worked really well, except when I originally made it, I made the motor mounting plate from this thin, I think it's 1.6 mil steel, and it was a bit too thin. And what would happen is, as the machine loaded up, it would actually start twisting a little bit. So this plate would start to bend and the chain would pop off. It wasn't helped by the fact that I had sort of rubber mounts and things in here, because I thought that would help with getting the alignment right and allowing for a little bit of misalignment. It turns out I didn't need any of that. So what I did is remade this plate out of 3mm thick steel and just hard mounted everything. I just made sure everything's aligned properly, and that works much, much better now. Also, when I made the original plate, I didn't have the mill. So to allow adjustment up and down to change the tension on the chain, I just drilled oversized holes and used washers to lock it in place. Obviously, with a mill, you can do things like machine slots, which is much, much better because now I can just adjust this up and down. It doesn't wobble side to side. And one of the things I like to use this for with these homemade rollers here, this is just scrap of plastic and some 3mm thick steel plate. This would have been an offcut from something when I would have drilled a hole through something, and that was the center of the hole basically. And I use that to put in, obviously you can use the bead roller to do curves like this. This is very good if you're joining two panels at 90 degrees. You put effectively a curve in one and then the panel coming up a curve in the other, and you can weld along the flat but get that 90-degree bend, which works well. And you can also put in steps and things. But I use those wheels on the machine there to put in a kind of like a score line in the metal. It's like a break line into the flat sheet, because then when I go to bend up the flange, it'll bend along that line, and I find I can get much, much neater folds, bends with that. So I couldn't do that on the radiator shell for the flange on the front, because there's no way to get the machine past. It gets in the way of the machine basically. But I'm hoping I can do it on this back fold, because I can do it all on this side with the wheels in here, and I can just go up and around and make a nice score line so that when I fold over that back edge, it's all nice and tight and completely square. The other thing I did was just a little bit of maintenance on my wheeling machine. I got sick of having to put little shims made from soft drink cans under one side of the lower rollers to get the rollers parallel, because you need them to be parallel, obviously, to the top wheel. So I just carefully used a little sanding drum on a Dremel and just took a fraction out of one side so that everything would sit level. And at the same time, I took all of this apart and just re-greased it and made it a lot nicer to use. The whole time I was making that radiator cowling, I only managed to run over my finger once, which was good. I don't recommend doing that. It's very sore. Obviously, keep your fingers well away from the rotating parts.